that's the 1D model. Seems simple, right? So of course, the world is not as simple as one dimension. If it was only that simple. So, what you predict here is that the real world here is n-dimensional, right? So in the real world of you trying to get to your goal, I'm just only going to draw, a fake 3-dimensional thing here, but really it's higher dimensional, right? It's hundreds or thousands or millions of dimensions. So I'm going to draw 3D here. So imagine you're starting here, and my 3D is terrible, but your goal is there, right? And this is all in 3D, so you don't actually know where this thing is. So I'm going to generalize to n dimensions, but I'm just going to draw it actually in 2D because it makes it look simpler. So this is 2-dimensional, but imagine if this is, an arbitrary number of dimensions. So you're starting, so imagine you're in the wilderness somewhere, and you're starting here, and your goal is, I don't know, here, right? But the trick here is that you can't actually see it, right? Because if you could see it, then it reduces to a 1-dimensional problem again. And no matter what amount of dimensions you're in, it reduces to a 1-dimensional kind of path to the goal, right? Because that would be way too easy. So as Randall said, if there's a tree in your way, if there's only a single tree, if there's a whole forest in your way, I like that analogy. You're in a forest. I like that. If there's a whole forest in your way, you obviously can't see clearly the goal. So this 1D analogy of keep moving is actually terrible advice, right? Because what are the chances that your initial, so you both have a magnitude of your vector now and a direction, right? You have a direction you're going in here. So the 1D world of keep moving is actually terrible advice, because if you keep moving, you're probably going the wrong way, right? You're most likely, you're not, nobody points it exactly the right way. And if you're even a little off, you're really hosed, right? If you're only a little bit off from the right goal, you're still way off in the end because you're too far away. So what's the solution here? The solution is to so the kind of way to make this model a bit more robust is you still should keep moving. I think this advice still holds. I mean, this is still very true, because if you don't move, then you can't get there no matter what, right? However high dimensional it is, however close it is, if you don't move it, you'll never get there. So keep going back to this keep moving thing. And then in the second part of this talk, I'll tell you about how to actually do this. So basically the second model is keep moving with some caveats, right? So basically you want to move a bit, and then you want to stop and look around and get unstuck and try to figure out where your next course correction is, right? So you want to move at a good pace, then stop and course correct. And then you want to move at a somewhat good pace, then stop, and then course correct.
There's all these obstacles around.
Yeah, there's all these obstacles
Big
everywhere.
rocks and things like that.
Big rocks, trees, streams, whatever. It's like your wilderness survival movie. And so you're going here, and then you're kind of looking around and course correcting, and eventually, you do get there, right? So I mean, you do this enough times, and your path goes like this, and with every step along the way, there's some course correction. You might, go like this. This is very possible, and then you'll eventually get there. And the main added thing here is that you have this course correction. So, basically this means you need to be able to move far enough so that you can get to your next point where you course correct. What is this kind of the stopping in the form of? So one way to imagine this is, as with all design or engineering processes, is you need to be able to get feedback along the way, right? I mean, if this gap is 6 months that you're just walking in one direction, or 1 year or more, then you're probably in trouble, because you need a lot of these course corrections along the way, right? So I guess the one actionable thing here is you really do need to get feedback pretty rapidly. Because if you don't, then the chances of you, especially if you're just starting, pointing yourself in the right, most likely you might be pointing yourself in this direction, right? The chances of you pointing in the right direction initially is almost zero. And the goal of these course corrections along the way is to get you eventually closer and closer there. So this comes in the form of several things, right? So this comes in the form of the kind of simplest form of this is to have meetings with your advisor, say, right, or your research advisor collaborators. The kind of more frequently and more useful these meetings are, the better you can perhaps course correct, right? And this this gets into a whole big topic in itself. Also, understanding the field better and getting more experience at this. And I'm a big believer in the keep moving thing, because even if your initial direction isn't right, as you keep moving, the physical analogy doesn't work here, but as you keep moving, you're actually, I guess it does, right? As you keep moving, you're understanding more about your terrain, right? So one of the only ways to develop intuitions about the space you're carving out is just start doing stuff around it or in it, that's somewhere that you're sort of interested in.